Okay. For number 8, perpendicular bisector, I know that these two lengths, QS and SR, will be set equal to each other. Solve for x, then plug x in to find the length of SR. Number 9, these two angles are equal to each other. This is a converse angle bisector theorem. Since these two angles will be equal to each other, set them equal to each other, solve for x, then plug x in to find the whole angle, not just half, but I'm going to plug it into the first one or the second one, whatever I get, I double it because these are equal to each other. Okay, I want to make sure we always mention 3. The 3 perpendicular bisectors of a triangle intersect at a circumcenter. 3 angle bisectors intersect at the incenter. The blank of a triangle intersects at the centroid, that's a median. And orthocenter is altitudes. Okay, so Z is the circumcenter of the large triangle STU. SY is 19. Well, this is made up of perpendicular bisector, so if this side's 19, then I know the other side is 19. TZ is 21. Now, perpendicular bisectors, the circumcenter is equidistant from each vertice. So if this is 21, I know every other leg is 21. Okay, ST is 30. So the whole side is 30, which makes each of these 15. Find each measure. So I want to find SZ. SZ, that's going to be 21. YU, got it, 19. WT, 15. And ZY. Where's Z? ZY. So I need to find this little leg right there. I'm going to use the Pythagorean theorem. So 19 squared plus my unknown squared equals 21 squared. Okay, so once you have this set up, use your calculator to square both of those and then solve for x. When you get your final answer, 19 squared is 361. (21 squared is 441. Subtract 361. Well, it's not 264, it's 80. X squared equals 80. Take the square root of both sides. About 8.9. Okay, you're going to use the same thing for 15. Same exact ideas. We know that these are all bisectors. We know that these 3 inside legs from the circumcenter to the vertices are all the same length. Okay, now number 16, the incenter. QT is 5. QT is 5. VU is 7. So if this leg is 7, incenters from the incenter to each side is the same length. So I can mark all of those legs. PV is 29. Okay, and find the rest of the measures. So I want to find SV. Got that, that's 7. QS. Okay, these are going to be congruent triangles. Okay, they share an angle measure. This has to be 90 degrees. This has to be 90 degrees. Share a side, and we have a leg or a hypotenuse that's congruent to each other. So by HL, these two can be congruent, and by angle bisector theorem, these two were bisected, the angles, so those two are congruent. So I know that SQ will be the same length as QT. Now I need QV. So I'm going to use the Pythagorean theorem to solve QV. So 5 squared plus 7 squared was x squared. 25 plus 49 was x squared. Am I setting this up wrong? PV. QV. Yeah. No. 47 or 74 is x squared. Take the square root of both sides. Get about 8.6. So I need to find PS. Again, the Pythagorean theorem. 7 squared plus x squared equals 29 squared. Again, solve for S. Next page. End center. Again. So, same process. These two are going to be equal to each other. You could solve for x. This is 47 degrees. That's going to be 47 degrees. And then you can start to solve for the angles all the way around. Once you know this entire angle and this entire angle, you can solve for this angle and the bisectors within it. Okay, centroid. This is the 2/3 one when you have a centroid. So PN is 5. So if this short side is 5, I know that the other side is double it. That would be 10. LM is 33, so the entire thing is 33. So I need to break it up into thirds, so I divide 33 by 3, and I get 11. So I know the short side of this entire thing is 11. The longer side is double that, which is 22. So 11 plus 22 adds up to 33. Now I need KP. The long side is 16. So I know the other side is half of that, which is 8. And now you can solve for all the missing sides. Classify each triangle by the center. Okay, so I have perpendicular sides, or perpendicular lines, but it is not cutting the side in half, so it's not a perpendicular bisector, which only leaves altitudes. So these are altitudes. Cutting the angles in half, well, so these are altitudes, that makes that an orthocenter. Cutting the angles in half, so these are all angle bisectors. 3 angle bisectors make an end center. Okay, from the middle of the side, midpoint, to opposite vertex. Middle means median. Okay, triangle inequalities. So we add up the two shorter sides. 5 plus 2 must be greater than 10. 7 is not greater than 10, so no, that cannot be a triangle. Same thing, you add the two shorter sides all the way through. Okay, now we're checking. So let's say we're going to see if all the range for the possible third side. So 3 plus the unknown must be greater than 48, or 3 plus 48 must be greater than the unknown. Solve for x and you'll get your range.